Hey everyone, John Blankensop here, and welcome to another Big Q University Knowledge Nugget. In this edition, we're going to be discussing another Big Q quality management universal process called quality control. I hope you find this edition insightful and informative. Let's begin by reviewing what we know regarding how organizations provide confidence that quality requirements will be fulfilled within their organization, or the definition of quality assurance. Well, Dr. Durand felt that that was done by the integration of the universal quality management processes into management thinking and everyday working practices. Those universal processes are called the Durand trilogy: quality planning, quality control, and quality improvement. And it's important to know that quality control is an output of quality planning and becomes an input into quality improvement. The three of these universal processes working together sets up the plan, do, check, act dynamic within an organization. The definition of quality control is the part of quality management focused on fulfilling requirements and achieving objectives. Now, when we talk about the universal processes, I like to use the three-legged stool. The three-legged stool is the quality management system that stands up the organization. And the three legs are quality planning, quality control, and quality improvement. And we've talked about how those three legs have to be equally strong to keep the quality management system standing up and supporting the organization. Now, Duran broke out quality control into these steps: choose process controls, choose units of measure, establish monitoring and measurement provisions, establish standards of performance, measure actual performance, interpret the difference between actual performance and the standard, and then take action on the difference. Quality control is the method carried out every day to assure we're making and delivering the products or services to the right targets. It's a system of product and process controls which can provide stability to the operating process. Also, it maintains control of product and or service features or key product characteristics required to meet customer needs. We can think of quality control in two ways. We have what we call after the fact inspection, which is detection control, and then we have prevention, which we call proactive control. So another way for us to think about this is shift our mindset from process conformance to process control. When we start with process conformance, we're talking about the reactive detection control, conformance within output spec limits, an affirmative indication or judgment that a process output has met the requirements of a relevant specification, contract, or regulation. And if we use statistical control methods or tools to support process conformance, we call it statistical quality control, or SQC. And it can be defined as application of statistical and analytical tools to monitor and measure process outputs, or what we call dependent variables. Now, when we shift our mindset and we move from process conformance to process control, we shift into what we call proactive control, performance of a process within process control limits. It's the method for ensuring that the inherent design of a process, the input variables, meets specified requirements. And if we use statistical methods or tools to support this proactive control, we call it statistical process control, or SPC. And it can be defined as the application of statistical and analytical tools to control process inputs, what we call the independent variables. So now let's look at an example that shows us this shift in mindset from process conformance to process control. Well, first of all, we're going to take a look at our process depiction in the SIPOC orientation. In the middle, we have planned process activities that take inputs from a source and turn them into a result or an output that is delivered to an output receiver. In the middle there, we have our quality planning, quality control, and quality improvement. We're going to be focusing on control, the measuring and monitoring part of this. Now, we know that the quality of a process output, the green Y, is a function of the quality of the process inputs, the red X's. So the first example we're going to take a look at is process conformance, which focuses on the green Y. Remember we said it was after the fact inspection or detection control. In this example, we're looking at an output shaft and we're measuring the outside diameter of that output shaft. And we're determining if that outside diameter is within the specification limits. And you can see in this case, the actual measurement is within the specification limits. Now, with this approach of control, I have to inspect 100%, and I have to react to the process after the nonconformance is detected, usually downstream from where the item was manufactured. Now, if we shift our mindset to process control, I'm focusing on the red X's instead of the green Y. I'm still measuring the output shaft, but now what I'm taking a look at is one of those input variables, which is machine. And what I'm trying to understand is how well does that machine target the ability to meet the nominal requirement for outside diameter, and what is the amount of variation or process spread off of that target. If I'm able to target nominal very well and my process spread is very little compared to the specification limits, then I not only have a process that's in control, I have a process that's capable. And what's different about this kind of control is I'm not inspecting 100%, I'm sample inspecting. And I'm reacting to process before a nonconformance occurs, not after a nonconformance occurs. Another quality control approach is something that's called quality at the source. Quality at the source is a lean manufacturing principle which defines that quality is not only controlled at the end of a process, but also at every step in the process. It can be operator controlled or it can be machine controlled. And our mantra for quality at the source is we accept no defect, we make no defect, and we pass no defect. Now, to create quality at the source, we need to use Big Q quality management, advanced quality planning tools. We've got to be able to predict and prevent defects from occurring, and we've got to be able to protect against defects that do occur from passing through the process. Now, based on factors like criticality, risk, throughput requirements, and return on investment, we can come up with different levels of quality control strategies to support quality at the source. The first level is called cannot pass. Cannot pass is where we can detect and contain a defective product from reaching the next operation in a process or from reaching the customer. Then the next level would be cannot process. This is where we can provide feedback to the operator that a defect has occurred so that the operator can intervene and not continue to process. And then the last level is called cannot produce. And this is where we can implement controls that prevents defects from occurring. So to close, let's review the last three steps in Duran's quality control. It was measure actual performance, interpret the difference between actual and the standard, and then take action on the difference. So what was he talking about? Well, when we think about the provisions of cannot produce or cannot process, we could have machine controls, and the machine could react to a mistake or a nonconformance to rectify it. We could have operator control via a control plan, and the operator can react in accordance with a reaction plan. Then if we focus on cannot pass, we would have an inspection plan that was executed, and if there was a nonconformance detected, there would be a reaction plan, most likely invoking the nonconforming output management procedure and kick off a corrective action. Well, that's going to be a wrap for this Big QU Knowledge Nugget. I hope this edition piqued your interest and intellectual curiosity. And I hope you plan to join me for the next Big Q University Knowledge Nugget. But until then, remember, every day is a great day to make things better. See you next time.